Hi, this is Brandon Baines in the Math Department at Lipscomb University, here to talk with you today about applications of systems of linear equations. In this presentation, you'll learn how to solve systems of equations in applied settings. After viewing this presentation, you may see more of the benefit of solving systems of equations as compared to the previous presentation. Here's an example of a system of equations in context. A bicycle shop has 36 bicycles and tricycles combined. When the wheels are counted, there are 80 wheels in all. How many bicycles and how many tricycles are there? Well, to solve this problem here, we first need to write some equations. So sometimes this can be the tricky part to solving systems of equations in applied settings, is coming up with the equations. But in the scenario, we were told that there are 36 bicycles and tricycles altogether. So if we let X represent the number of bicycles and Y represent the number of tricycles, then we can make this statement X plus Y equals 36. Second, we are told that there are 80 wheels altogether. We know every bicycle has 2 wheels and every tricycle has 3 wheels. So that can give us an equation for the 80 wheels. That is 2x plus 3y equals 80. Using the method of graphing to solve this system, we can graph both of these equations and observe where they intersect. And they intersect at the ordered pair 28, 8. That is when x is 28 and y is 8. So we can conclude that the shop has 28 bicycles and 8 tricycles. Let's look at another example. A young child is currently on a diet of milk and cereal. The milk has 8 grams of protein per serving and 150 calories per serving. The cereal has 5 grams of protein per serving and 120 calories per serving. The young child's diet requires that she consumes 58 grams of protein per day and 1,140 calories per day. How many servings of milk and how many servings of cereal should she eat? Again, to solve this problem, we need some equations. And so this child is eating 58 grams of protein per day, and her sources of protein in this scenario are milk and cereal. So if we let X equal the number of servings of milk and Y be the number of servings of cereal, then we have the equation 8X plus 5Y equals 58. This is 8 grams of protein per serving of cereal, 5 grams of protein per serving of, 8 grams of protein per serving of milk, and 5 grams of protein per serving of cereal. Second, we are told that the child needs 1,140 calories per day, and so we can come up with the equation 150x plus 120y equals 1,140. The 150 coming from the calories per serving of milk, and the 120 coming from the calories per serving of cereal. Just to mix up our solution methods, we'll use the method of substitution here. Should note, you could graph these two equations and see where they intersect. That would work as well. So I'm choosing the method of substitution just to diversify our solution methods. Beginning with step 1, we'll take the equation 8x plus 5y equals 58, and we'll isolate the y variable. And that gives us the equation y equals negative 8/5 x plus 58/5. So now we have two names for y. We can say y, or we can say negative 8/5 x plus 58/5. Going to step 2 then, we'll substitute this value of y into the other equation. So we have 150x plus 120y, but again, instead of using y, we're using the alternate name for y. And that equation is supposed to equal 1,140. Now we have an equation that only has x as its variable. And so we can clean up and solve for x in step 3. Doing that, we find that x is equal to 6. And so we know now that the child should have 6 servings of milk, since x is representing our servings of milk. To find the number of servings of cereal, we can substitute this value of x equals 6, back into our equation from step 1, which was y equals negative 8/5 x plus 58/5. And so we've done that here. Instead of using an x, we've let x be 6. Cleaning up, that results in y equals 2. So we know that the young child needs 6 servings of milk and 2 servings of cereal per day.